All right, so this is section 3.5. It's on probability trees. And what I'm looking at is I'm looking at the first homework assignment for these probability trees. And the reason why I wanted to do this is because they're kind of tricky, and it is especially kind of tricky to figure out how we are going to figure out um, our conditional probabilities after we finish the probability tree. So a little instruction, maybe hopefully that'll kind of help you out with the second question. So, a certain virus infects 1 in every 400 people. A test used to detect the virus in a person is positive 90% of the time if the person has the virus, and 10% of the time if the person does not have the virus. Let A be the event the person is infected, and B be the event that the person tests positive. So I'm going to write those down. A, person is infected. And then what I'm going to use is I'm going to use the complement of A is the person is not infected. And then B is the person tests positive, and B, complement, is the person tests negative. One of the big ideas that we're going to use here is we're going to use, one, that the probability of A plus the probability of A complement are going to equal 1. Okay? And so that's one of the rules that we have for complements, if you remember, that the two of them are going to add up together to 1. So also the probability of A complement is simply going to equal 1 minus the probability of A. Okay? Now, the next thing that we're going to do is we're also going to have to remember that we have this conditional probabilities, specifically that the probability of A and B will equal the probability of A times the probability of B given A. So that's our conditional probability. That's what's called Bayes, right? Okay, or it's a kind of Bayesian statistics, and we're going to learn the other part here using the trees. Okay, so we want to remember those two things. This one here, that's going to become really important when we use the trees, as will this one over here. Okay, the idea that we add a number and its complement, and they're going to add together to 1. Okay, now, when I construct a tree diagram, I'm going to have a set of trees and a set of branches. Okay, each tree represents an event. So like, for example, a person being infected or not infected, I have A here and A complement. That represents a set of branches or a tree. Then, for each A, I'm going to have a B. So somebody can actually test positive given that they are infected. And I have a B complement, which is the fact that they test negative given that they're positive. And then in addition to that, I have B for if they test negative and they in fact are they test positive and they are in fact infected, and B complement if they in fact test negative and are in fact they do not have the disease. Okay. All right. So let's talk about now. So that's how that kind of gets set up, right? You have one event here. Okay, that's call that their infection. And then we have the B event here, which is called the test, right? A and B, and then we represent them using their complements. Now, what I'm going to do now is I'm going to put in the probabilities here. Well, the probability of A, right? A certain virus infects 1 in every 400 people. So the probability of A is going to equal 1 in 400, okay? Which equals 0.0, 0.0025. Now, the probability of A complement, okay, is going to end up equaling 1 minus 0.0025 because of this guy over here. Remember that? Okay. These two, they're complements of each other, so that probability is going to just end up equaling the complement. Okay. So we have 1 minus 0.0025 equals 0.9975. Next up, we continue to read a test used to detect the virus in a person is positive 90% of the time if the person has the virus and 10% of the time if the person does not have the virus. So this B here, okay, it's what we're looking at actually is we're going to find the probability of B given A. Okay? And that is specifically the probability that somebody tests positive, right? Tests positive given that they actually have the virus. And we're told that that's going to equal 0.9. Okay? That's 0.9. And then what we know here is then that the probability of B complement, given that we have A, is going to end up equaling 0.1. It's going to end up being the complement of the other. Okay, so we have 0.1 and 0.9. I'm actually going to just put this on the endpoints. All right, so on the one hand, you can have the virus, that's A, and then on the other hand, you test positive. There's a 90% chance you're going to test positive, and a 10% chance that you'll test negative if you have the virus. Now, if you don't have the virus, what we're told is if the person does not have the virus, they test positive 10% of the time, right? And that's just really, read carefully, okay? So they're going to test positive 10% of the time. Remember, B is positive, and then they'll test negative 90% of the time, okay? 0.9. So what we're going to do now, okay, is we're going to use this, and we're going to use this fact right here, right? This Bayesian probability right there, probability of A and B, is equal to the probability of A times the probability of B given A. So we're going to multiply those two together to give me, right, the probability of A and B, probability of infected and positive, the probability of infected and negative, the probability of not infected and positive, and the probability of not infected and negative. Okay. So if I go up here, I'm going to just do some multiplication. I'll have 0.0025 times 0.9, and that equals 0.00225. 0.0225. So what I did there was I multiplied 0.9 times 0.0025. Then I'm going to take 0.0025 and I'll multiply by 0.1. And when I do that, that's going to end up giving me 0.00025. Just add the 0 on. Next, I'm going to figure out the probability that I'm going to have A and B. So what I'm going to do is I'm going to multiply this guy here by this. So I'm going to multiply the probability of A complement times the probability of B given A complement. So the probability that you do not have the virus times the probability that you will test positive given that you don't have the virus. Okay? So that's going to end up being 0.9975 times 0.1. And it's 0.09975. And then finally, I'm going to take 0.9 and I'll multiply it by 0.9975. 0.89775. And there we go. So that actually gives me all of my probabilities in terms of all my AND probabilities. Okay? So that actually kind of like is going to help us out a lot. So let me kind of review a little bit what it is that we did. So we actually set down as the two sets of branches for our tree. We set down the event and its. So what I did was I set down an event and its complement, okay, as the first tree, and that would be whether or not a person has the virus or does not have the virus. Notice that in my question, that person being infected, there's no condition on it. It's not if the person tests positive or if the person does not test positive, okay? So that's actually really important, and that's what sets it up as the first branch. There's no condition on it. The second set of branches, they both have conditions on them. B and not B are actually the condition that somebody actually has the virus in this case. And this B and not B are on the condition that somebody does not have the virus. So then what I did was I figured out my probabilities, first for A and B, I mean A and not A, okay? That is that has the virus and does not have the virus. And those add up to 1. Then I figure out my conditional probabilities. That is that somebody test positive and they have the virus, which we were told was 0.9. And then 1 minus, right, that 0.9 gives me the probability of B complement given A. And then I did the same thing for the bottom ones as well, utilizing the information that's sitting right here. Okay, the probabilities that we already know. Finally, what I did to figure out these intersections, A and B complement, A complement and B, and A complement and B complement, I utilized this formula right here. I multiplied straight across. This times this gives me that. This times this gives me that. Okay? And so consequently, those actually, that's how we end up with all these values. Right? Now, why? So what? I mean, like, I could have totally done that without doing this. So let's actually go to some of the questions that were asked here. So let's say, for example, I look and I've got find the probability that a person that has the given virus. Okay, let's write this. Let's put this in here. So what I've got has the given virus given that they have tested positive. What you'll notice is that we don't actually have that information readily at hand. We know that the probability that a person has tested positive given they have the virus. So that is that we know the probability of B given A, right? This is actually the probability of A given B. Okay, so let's actually write that down in order to help clarify things. We have the probability of B given A. This is asking for the probability of A given B. Now, it turns out it's not all that bad. Okay? All right, so this is the probability that somebody has the virus given that they test positive. What we're going to do is we're kind of use that whole idea of probability that we've used before. So how do we find this? Well, what we're going to do is the probability of A given B is going to equal the probability of A and B divided by the probability of A and B plus the probability of A and B complement. Notice that these two are the ones that we have, or all four of these we have. So on the one hand, the probability of A and B, okay, that's the probability that we're looking for. This is positive and virus. Okay, so we got positive probability of positive, or actually let's write it out as virus and positive. So that's what I'm looking for. That's my desired result. And I'm going to divide that by the probability that somebody has the virus and positive, and also plus the probability of no virus and positive. So all I'm looking for out of here is I'm looking at all the different positive ones, right? Because I'm looking for the condition if they're positive, right? And these two, virus and no virus, with the positive are all the occurrences where we have something that's positive. So if I look here, right, 0.0025 and 0.09975. Those are our two values. So the probability of A and B equals 0.00225, 0.00225, excuse me, and the probability of A and B complement are going to equal 0.09975. So the probability of B given A, excuse me, of A given B, that is that a person has the virus given that they tested positive, will equal 0.00225 divided by 0.09975 plus 0.00225. There we go. And so that's how we find it. All right. Let's take a look at another example, right? And I'll allow you to just go and put that in your calculator. Let's take a look at another example. Let's look at the second one. Find the probability that, well, let's put this down here first before I do it. Okay. Find the probability that a person has a virus given that they tested negative. Okay. Well, here's what's going to happen. What we want to know the probability, okay, that a person does not have the virus. So that is A complement given B complement. That is that they tested negative. So that's going to be the probability of, and what we want to know is the A and B, A complement and B complement. Notice they match up. Okay. And then we'll divide those by the probability of A complement and B complement plus the probability of A and B complement. Okay. So these are all, notice that these are both negative, right? Okay. That's the given, right? Given they've tested negative, so that's the ones where we've got to match up the event, right? And then you just plug in the numbers for those, and you go and you plug them into your calculator and you solve. All right. I hope this was helpful. Basically, that's what we're looking at, right? Okay. We set up our tree, given what I talked about inside of the tree, right? One event, two events, we plug in our values and then multiply. And that'll give us all of our ands, right? Our A and B complement, A complement and B, A complement and B complement. And then what we do in order to find these conditional probabilities is we're going to have the A and B, right? The one that you're looking for, right? Notice it's A and B, and it'll divide it by the probability of A and B plus the probability of A complement and B. Excuse me. So we want only positives. Same thing down here, A complement and B complement, and then we'll have A complement and B complement plus the probability of A and B complement. Okay? So I hope that helps.